Howdy and good day, fellers. We are here in Algebra reviewing CO22, how to find slope from a graph or given two ordered pairs. We're going to go through the quiz today, which went quite well. Very impressed. The eighth graders, you've seen this before. Seventh graders, you're catching on quickly. So awesome job to all. There's just one that I really want to talk about at the end of this quiz here. And then we'll get into CO23, and that will wrap up the Friday. Hope you had a great week. New Khan Academy has been assigned. And so once you are finished with the CO23 quiz, if you got time, if this video doesn't last for 35 minutes like the other ones, you can work on Khan. It is due Thanksgiving night, and you'll probably have other things going on during Thanksgiving Day. And so getting that Khan done ahead of time will very much behoove you. If you've got math packet number 4 and want me to check it over the weekend, leave it on my desk, please, and I will pick it up when I come in. So, to the quiz. The PO22 quiz, the whole point of this is to find that vertical change over the horizontal change. And the formula that we talked about is y2 minus y1 over x2 minus x1. Okay, and so if these are the two ordered pairs that we're working with here, 8, -10, and 22, 30, go ahead and label x1, y1, your first x, your first y, then your second x, and your second y. Okay, and then you just plug them into the formula. And I think if you're making mistakes, either you put your x's on top when they should be on the bottom, right, and vice versa, or negative signs just tripped you up. Because like we talked about, this subtraction sign, part of the formula has got to be in your calculation. This negative sign, which belongs to that 10, also has to be a part of your calculation. So when you plug this in, y2 minus y1, it is going to be 30 minus -10. Okay, which ends up being 30 plus 10, right? And then x2 minus x1, 22 minus 8. That gives us 30 plus 10, 40 over 22 minus 8, which is 14. You'll notice that 40 over 14 is not one of the possible answers. That is because slope being a fraction, yes, it should be simplified, and we get 20/7. Okay, so if you got 7/20, then you flipped them. You put your x's on top, y's on the bottom. If you got 10/7 or 7/10, then instead of adding here, you subtracted to get 20, right? So one mistake was with the position of your x's and y's. The other mistake was with that negative sign. So maybe take a look back at your quiz. You should still be able to view it. If you got that one wrong, take a look at which mistake it was, and then you can start to correct. Next one. Oh, I forgot how fast it scrolls. Same situation here. You got that -2. So when we label our ordered pairs, x1, y1, x2, y2, and we take that y2 minus y1, it is going to be 18 minus -2. The subtraction sign from the formula and the negative sign that belongs with that 2. x2 minus x1, 0 minus 5. 18 plus 2 is 20. 0 minus 5 is negative. Nope, I jumped the gun a little bit. -5. Okay, and like any other fraction, we can simplify this. And if you simplify it, to be -4 over 1, you'll notice that -4 over 1 isn't one of the options here, but slope is supposed to be a fraction, right? Well, remember, -4 is the same thing as -4 over 1, which makes this first option the correct answer. If you gave me this on a test, I would mark it incorrect because it should be simplified. If you gave me this on a test, that would be fine. Because even though -4 over 1 is just -4, because it is slope, identifying that the run is a positive 1 is not a horrible thing. It's in context of what slope is. And so I would accept either -4 or -4 over 1, but not 20 over -5. Okay. And by the way, if you're kind of thrown off here because the denominator's negative with the -5, but the numerator's negative with that -4. Just remember that as far as negative fractions go, -20 over +5 is the same thing as +20 over -5 is the same thing as -20 over 5, kind of putting that thing right in front. Okay, all three of those things are the exact same value. They all equal -4, and they really, yeah, it wouldn't matter where that sign goes as long as there's only one of them. So that's the story behind that. Number 3, slope of the line that passes through 3210 and -12 at -15. Again, x1, y1, x2, y2, y2 minus y1, -15 minus 10, x2 minus x1, -12 minus 32, -15 minus 10 is -25, -12 minus 32 is -44. The only simplifying that can be done here is that we are dividing a negative by a negative, which actually then kicks out a positive value, 25/44, which is the fourth option there. Okay. The one that if there's anyone that gave people the heebie-jeebies, it was the last one here. Which set of ordered pairs below has a slope of 5/7? Now, you can't really make fractions very well in Google Forms because Google and I don't get along well, and they said, no, you want to put a fraction, we won't make it that clean. But 5/7 is the fraction 5/7, right? Which when we talk about slope means that 5 represents the change in y, and that 7 represents the change in x. That's what slope is, change in y over change in x. So what you're looking for here is which ordered pairs have y values that are 5 apart, right? Because we got that 5 by subtracting our y values. 15 minus 8 is 7. So this one was the one that was going to try and trick you. 15 minus 8 is 7. 6 minus 1 is 5. But because the y values give us the 7 and the x values give us the 5, that's going to be a slope of 7/5. So if you flip the numerator and the denominator, your x's and your y's, then you probably selected that one. The second one, 11 minus 6 is 5. 10 minus 3 is 7. Ding, 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 ding. Number 2. Okay. The difference from 11 and 6, our two y values, is 5. The difference of 10 and 3, our two x values, is 7. So change in y, 5, over change in x, 7. Those would be the two ordered pairs that give you that slope. There is a question like this on your test. Okay. So if you still aren't quite sure about it, then we'll go over the other two on your page. Maybe send me an email and say, hey, this is what I got on my homework. Is it correct? Does this work? And I think there's something like this on the practice work also. So if you want to flip over to the practice work and do it as preparation for the test, rather than wait till after, only if you have to, it is good practice. Any practice is good practice. But all in all, fantastic job. 7th graders especially, learning it for the first time. Quite impressed. So here is what your homework was. We did this one already on the quiz. For this one, x1, y1, x2, y2, you have -7 minus 0, and then x2 minus x1, -18 minus 1, which would give you a -7 over -19. You look to simplify this, the only thing you can do, negative divided by a negative is a positive, and so 7/19 would be the answer. 7/19, positive 7/19. Did this one on the quiz, did this one on the quiz. This one here, x1, y1, x2, y2. y2 minus y1, 14 minus 9. x2 minus x1, 3 minus 3. 14 minus 9 is 5. 3 minus 3 is 0. You probably know that you cannot mathematically, legally, divide a value by 0. If you've got Siri on your phone, I think we did this in geometry, go ahead and ask it what something divided by 0 is, and it'll give you a pretty neat response. But in the slope world, What this means is that there's a run or an x movement of 0. So it's not going side to side at all. A vertical line will have a slope of 0. There's no run. There's no horizontal movement. It's going straight up and down. Okay, which means that the slope is undefined. Okay, in order for slope to exist, there has to be some horizontal movement. You wouldn't go to the ski slopes and go down a slope that's just a literal straight drop down. Like you literally walk off the edge of a cliff and down you go, like Wile E. Coyote, right? There's got to be some sort, no matter how steep it is, some sort of horizontal movement for you to slide on, okay? So with a denominator of 0, undefined slope does not exist because it's a vertical line. The last one, x1, y1, x2, y2. We've got 5 minus 11 and negative 11 minus negative 5. There we run into that minus negative again, right? Because that subtraction sign from the formula coupled with the negative sign of the number, you got to include them both. 5 minus 11 is negative 6. Negative 11, essentially plus 5, is also negative 6. And so this slope is just 1. If you put 1 over 1, that's acceptable because it is slope. It shows the run is 1. There you have it. Negative 6 over negative 6. Then more kind of like the ones we had on the quiz where you had to give me ordered pairs. So for this one, 2 ordered pairs with a slope of 2/3, it means that your y values should be 2 apart and your x values should be 3 apart. So look at the 2 ordered pairs you have. Look at your y's. Are they 2 apart? Look at your x's. Are they 3 apart? If they are, then you're probably correct. If you threw negative signs in there, that might throw some things off a little bit, but generally that's how you can look. For a slope of negative 8/5, I'm going to rewrite this fraction as negative 8 over positive 5 or positive 8 over negative 5. Okay, so this time when you look at your y's and your x's and you plug them in that formula, y2 minus y1, either they still need to be 8 apart, but one of them has got to be negative. Either your y's have to be a negative 8 and your x's subtract to be positive 5, or your y's subtract to be positive 8 and your x's subtract to be negative 5. They can't both be negative because a negative 8 over negative 5 is actually positive 8/5. That wouldn't work. Okay, so this might be a one where if you're not confident, you got to either ask a friend or send me an email, say, hey, this is what I got. Is it a slope of negative 8/5? And I can confirm it. Then write 2 ordered pairs with a slope of 6. We're going to rewrite that 6 as a fraction, 6 over 1. So your y values should subtract to be 6. Your x values are only 1 apart. They should subtract to be 1. Okay. And that wraps up PO22. Onward and forward to CO23, where we're going to learn today about something called Slope-Intercept Form. I've always told kids that if there are 3 equations, the 3 most important equations that I will teach you, Slope-Intercept Form is going to be one of them. Pythagorean theorem is going to be a second one. And the quadratic formula is going to be the third. Okay, and so here we start with Slope-Intercept Form. And what Slope-Intercept Form does, why we like it, why we are friends with Slope-Intercept Form, is it clearly identifies the slope and y-intercept, that might be a new term for you, of a linear function. The more we work with equations and graphs and the coordinate plane, you're going to start to pick up characteristics. You're going to start to pick up patterns. You're going to start to be able to look at an equation and know what the graph of that equation is going to look like. Or you're going to start to be able to look at a graph and know what that graph is in equation form. And one of those big clues that we can use is what's called slope-intercept form. Okay, of course, slope is how a line moves across the coordinate plane. Rise over run. Let's have some fun. Okay. We talked about that in PO22. And then the y-intercept is the points where the line crosses the y-axis. The point where the line crosses the y-axis. Those are all definitions of the slope-intercept form and the slope and the y-intercept. Here's the actual formula. The key point, recommend it goes on a help sheet. Slope-intercept form is y equals mx plus b. Y equals mx plus b. And for today, we're really only going to care about the m and the b, because the m variable in this formula represents our slope. That's the slope. And you might be wondering, well, why isn't it an S? Why did they use m to represent slope? Well, as you probably know, math started a long time ago, and originally slope was actually called mlope, M-L-O-P-E, mlope, okay? But then as the years passed and it got translated from language to language or whatever, it's the slope that we call it today, but the m variable stuck. So it was originally called mlope, and that's why they use the m variable for slope. The b variable in the equation represents the y-intercept. I should write that so you can read it, so you can spell it. The y, oh, it's already on your page, duh. The y-intercept. The b variable tells you where that line crosses the y-axis. And why in the world would they use a b? Okay, well, that's because when math was first being discovered and written down, it was actually called the y-bintercept. The y-bintercept. But over time, the b got dropped off, and we're left with the y-intercept we have today, but that b variable stuck with it. Okay, trust me. Don't Google it though, but trust me. Okay, so here's where slope-intercept form can help us to identify the slope and y-intercept of a line. Let's look at this. Y equals 7x plus 3. And I want you to see an equation like this, where y is by itself, and we have an x variable on the right side. This is slope-intercept form classic. Look, y equals mx plus b. So the m variable, that coefficient to x in this equation, is 7, which means the slope of the line is going to be 7, or if you want to write it, 7 over 1. So just by looking at the equation, it gives you some information about it. This is going to be a pretty steep line, isn't it? I mean, 7 over 1, just sketching ordered pairs here, I'm going up 7 on the y-axis and only over 1. Okay, there's a black diamond ski slope for you right there, right? But it still has some horizontal movement, so it's still a legit slope. But 7 over 1. And then the y-intercept, that b variable, is positive 3. Yes, this sign belongs to it, okay? It's positive 3, which means that this line is going to cross the y-axis at 3. And being an ordered pair, we need to write 0, 3, because that is the ordered pair of 3 on the y-axis. For the y-intercept, if you're unfamiliar, the x value will always be 0. And then whatever the y value is, well, that's where it crosses the y-axis. This next one, y equals 3/5 x minus 6. y equals mx plus b. Our m, that coefficient to x, is in fraction form for us. Kind of makes it sometimes easier to recognize we are in slope-intercept form, but the slope is going to be 3/5, meaning from, again, just sketching points, from one point to the next, we're going up 3 over 5, right? It tells us some information about this. We can visualize what that's going to look like on the corner plane. And then the y-intercept, the b variable, yes, that sign's included, -6, it's going to cross the y-axis at 0, -6. Okay. The last one here, y equals -7/2 x plus 3. Put plus 3 twice in this little example section. I'm not quite sure why. But our slope, our coefficient to x, -7/2, which means this one, again, just sketching, it's going to be going down 7 and right 2. -7 over +2. So our line is going to look like that. So it also tells you, I mean, if you've got a positive slope, such as 7 over 1 or +3 over 5, it tells you kind of this line is going to be going up from left to right. This line is going up from left to right. If your slope's negative, now it's going down from left to right. Okay? So all of these clues from this equation give you information about the line. Then the y-intercept, that b value, +3. So it's going to be crossing the y-axis at 0, 3. Whew, take a deep breath, let you absorb that. Okay? That's what slope-intercept form tells us. So when we're given a graph and asked to find the slope and the y-intercept, well, we already looked at how to find slope when we have a graph, right? I've got two ordered pairs here. How do I get from one to the next? Up 1 over 4. So my slope for this first graph is 1 over 4. Where's it cross the y-axis, right? I'm going to put a blue dot where it crosses the y-axis. It crosses the y-axis right there. Remember, the y-axis is the one going vertically. It crosses the y-axis right there. What value is that? -1, right? Here's 0, the origin, and -1, -2, so on and so forth. So our b value is 0, -1. Those who really want to bring this home, and this is, I think, is a later objective actually, but what would the equation of this line be? Well, if slope-intercept form is y equals mx plus b, and we know m is 1/4, and we know b is a -1, here's the equation of that line on that graph. Y equals 1/4 x minus 1, mx plus b, our slope and a y-intercept. The next one, got a point here. Ooh, I'm traveling a long ways, going up, what is that, 5 and over 10. Ooh, goodness. Up 5 over 10. Of course, we are going to simplify 5 over 10 to be a slope of 1 over 2, right? 5/10 simplifies to 1/2. And like we talked about yesterday, we can do that because if I start here and go up 1 over 2, I'm back on the line again. Up 1 over 2, up 1 over 2, and so on, and so forth, and so on, and so forth, right? And then where's it cross the y-axis? I'm going to put a little blue dot where it crosses the y-axis. It crosses the y-axis at +4. And so our b value is going to be +4. Those who want to go the extra step here, what's the equation of this line? Y equals mx plus b. Uh-oh. No, my board is reconnecting. Hold on. New firmwares. What's the difference between software and firmware? I don't know enough about technology. That's why I have a flip phone. Anyway, so y equals mx plus b. We know our m is our slope 1/2. We know our b is positive 4. So y equals 1/2 x plus 4 is the equation of that line. Okay? Nifty. Slope-Intercept Form. Great stuff. Okay. But here's the thing, is that equations will not always be given to you in Slope-Intercept Form. Sometimes they will be in what's called standard form. So I'm going to kind of cross over 2 pages here. Standard form of an equation looks like this. Okay, ax plus by equals c. And notice that b is capitalized, so it's not the y-intercept. The y-intercept is a lowercase b. That capitalized b just represents a coefficient to y, whatever the coefficient is. Okay, but we remember back in CO12 where you had to solve for a literal equation where you just moved variables around from one side to the other. And I was like, you're not really going to use this a whole lot, but it's planting the seeds for a future objective. Well, here we are. Here's our future objective. Because from standard form, such as 4x plus 2y equals 12, our goal is to write this in slope-intercept form, which means we need to take this equation and essentially rewrite it so y is by itself, or solve for y. Okay? And so the 2 steps that you do to convert from standard form to slope-intercept form, step 1, use opposite operations to move x term to other side. Okay? Use opposite operations to move the x term to the other side. So in our first equation there, 4x plus 2y equals 12, using opposite operations, since it's a positive 4x, I'm going to subtract 4x from both sides. The opposite of a positive 4x is a negative 4x. On the left side, they cancel out. 4x minus 4x is 0. I'm left with just my y term. On the right side, 12 minus 4x, I can't get 8x out of that, right? Doesn't work like that. They're not like terms, okay? So I have to keep it separate. And here's where it gets a little bit tricky. Because in slope-intercept form, I want my x term first before my constant, rather than writing 12 minus 4x, I'm going to reverse that and put negative 4x plus 12, right? Essentially, in 12 minus 4x here, I've got a positive 12 and a negative 4x. I can either write that positive 12 minus 4x, or I can write it negative 4x and then my positive 12. Those 2 things mean the exact same. However, because I want to put it into slope-intercept form, I want that x term first. I'm going to write it negative 4x plus 12. Okay, so 2 things here. Number 1, you can't combine those. You can't get 8x here because the 12 doesn't have an x. They're not like terms, so keep them separate. Number 2, I'm putting my x term first, keeping that sign with it, negative 4x, followed by positive 12. Then step 2 is divide both sides by the coefficient to y. Okay, for slope-intercept form, I've got to get y by itself. So I need to divide both sides by, in this case, 2 to cancel that coefficient out of there. So 2y divided by 2, and actually let me write it the other way for division. 2y divided by 2, and when I divide the right side by 2, I've got to divide everything by 2, both terms actually, okay? And so that gives me, on the left side, y by itself, negative 4 divided by 2 is negative 2x. Positive 12 divided by 2 is positive 6. So converting from standard form to slope-intercept form, I can now look at this equation. When it's in standard form, you can't really look at it and tell what the slope is or tell what the y-intercept is, right? You put it in slope-intercept form, and now I can look at this and say, okay, the slope is negative 2. It's going down 2 over 1, and the y-intercept is positive 6. It crosses the y-axis at positive 6. Next one, 16x minus 4y equals 4. I'm going to follow the same 2 steps I used before. I've got a positive 16x. So to move that over, I'm going to once again subtract here. Minus 16x. And rather than writing it below, over on that right side, if you want to write it horizontally there, just because that's how it's going to look when you're done, that's not a wrong way to do it. You know, and it kind of helps remind you that on that right side, 4 minus 16x, that can't be combined. They're not like terms. That's the same thing as negative 16x plus 4, which is the way I want it, because I want that x term to come first. On the left side, my x's cancel out. And don't forget that sign belongs to that negative 4y. So step 2, when I divide both sides by the coefficient to y, that's what I'm going to be dividing by. Divide by negative 4. I'm going to do it to both terms on that right side. So negative 4y divided by negative 4 on the left is just y by itself. On the right side, negative 16 divided by negative 4 is positive 4x. And then positive 4 divided by negative 4 is a negative 1. So you see this connection back to CO12 here, right? We're taking an equation and we're solving for y, not getting like an actual numerical, a single number answer, but an expression. And we're just getting y by itself. Last one, positive 10x plus 20y equals negative 40. Subtract 10x from both sides. On the left, they cancel out. I'm left with a positive 20y. That sign comes with it. And then instead of writing negative 40 minus 10x, I'm going to put that x term first, negative 10x minus 40. Just switch them around. Keep their signs. Switch them around. Step 2, divide by my coefficient. So divide by 20. I wrote it as a fraction there, but I'll write it like this over here. On the left side, they cancel out. Negative 10 divided by 20 is a negative 1/2. Don't write decimals here, okay? None of the 0.5 stuff, right? Because if you look at an equation and it's y equals 0.5x minus 2, and I say, what's the slope of that? Well, 1/2. How do you know? Well, because 0.5 is a fraction is 1/2. Well, then just write 1/2, right? So no decimals for slopes here. Leave it in fraction form. Just simplify it. Negative 10/20ths simplifies to be negative 1/2. And then negative 40 divided by 20 is negative 2. And we're in slope-intercept form. Okay? All right. Your quiz is going to be on what you just saw. I'm not going to assign anything on the second page here. We'll kind of see how this quiz goes, and depending on if we need more practice, I'll go with it. If we don't, then I won't. We'll kind of see what Monday brings us. So go ahead, and I don't know how long this video is. I feel like it's a long one, though. Sorry. But go ahead and get into the Google Classroom. Take the quiz. It'll be on the notes that we took here. So obviously, you can use your notes on the quiz to help you. But get that done by the end of the day today so I can take Saturday and kind of see where we are at as a class. These quizzes are your homework, by the way. It's kind of my way of checking your homework rather than me walking around with my clipboard. This is me checking it in. So if you're not doing the quizzes, then it is going to affect your grade when it comes test time. in that homework score at the end of the unit. So hop on Google Classroom, take the quiz, leave your math packet for me if you want me to check it over. Khan Academy is out there for you to do as well. Practice work and retakes over the weekend. Remember, your practice work, if you're getting it from Google Classroom, do not open it in Google Docs. Instead, print it out as a PDF. And when you send me pictures of it, please make sure that it's in a well-lit area, that you're holding it up nice and close to the camera. I love all of your faces, but I don't need to see your face when you send me that practice work. Make sure I can see everything. I've got old eyes, so it's got to be nice and big and clear for me. But have a great weekend, folks. That is how you math. Do not forget to like and subscribe.